Today, what we're going to chat about is some more simplification of expressions, but we're going to talk specifically today about multiplication and division. Now, what we need to be careful of is when we multiply and divide, we need to be able to identify the terms that we're working with, in our expression. All right, so just a couple of reminders of things we have spoken about. We have spoken about this idea of like terms. Like terms are terms that have the same variable and the same exponent. Now, the reason like terms are so important is because when we start to add and subtract terms, we can only add and subtract like terms. So we're going to put a little note here. This is important when we add or subtract. Not when I multiply and divide. When I multiply and divide, I don't care about like terms. I do care about them when I add or subtract. Another thing that we've spoken about is what terms are and how we identify them. So remember, terms are separated by plus or minus signs in our expression. And so we need to be able to identify our terms in our expression so that we know exactly what terms we are working with and whether or not those terms need to be simplified. Now, when I say whether or not these terms need to be simplified, I'm talking about this operation or these operations that we're going to chat about today, which is multiplication and division. Now, another thing that's very important is understanding what can make up a term. So we spoke, I'm pretty sure it was in the first lesson of this course, we spoke about what terms are, what like terms are, what constants are. And so we've had a chat about this. But what I want you to just remember is that when you've got any variable, there will always be a coefficient part to that variable. So in this case, the 2, and there will always then be your variable, which is your letter representing your unknown. Now, anytime you have got a variable, so even if you just had the variable x by itself, there is always a coefficient to it. So when we've got a letter sitting by itself, there is always a coefficient of positive 1 to that variable. And it's very important that we remember that both when we are adding or subtracting our like terms, but also when we start to multiply and divide our terms. And we're going to chat about this more as we go along. So the first thing I just want to chat about is making sure that we understand what we are looking at when we look at an algebraic expression, and that we understand what terms we have in our expression. So I'm just going to leave this here for a second in case you want to take screenshots of those definitions. And then we're going to have a look at, I think there's 5 examples of just saying how many terms we have. I don't care about simplifying. I don't care about any of that just at this moment. I just want to figure out how many terms I have. So again, I'm just waiting for you to take screenshots if you would like those screenshots. And then we're going to have a look. Alrighty, so like I said, all I want to do in this first example is exactly as the instruction says, write down the number of terms in the expression. So I don't want to simplify, I don't want to do anything like that. I just want to know how many terms we have. So remember, if we just go back here, terms are separated by plus or minus signs. So when I want to identify how many terms I have, I need to look for my plus or minus signs. Okay, we're going to chat about this more as we go along. So if we start with question A, I'm just going to make this a touch bigger. Question A has no plus or minus signs. So let's put a little note for ourselves here, no plus or minus signs, which means that there is only one single term to this expression. So this expression has one term and one term only. However, when I then get to a question like question B, I can see I've got a plus sign there. And what that is doing is it is separating my first term of positive 4a from my second term of positive 2b. And so this expression in B has 2 terms. It is a binomial. You don't need to know that, but it has 2 terms to it. So based on that conversation that we've just had, in the chat, I want you guys to write down for me how many terms the expression in C has. So how many terms does C have? Put it in the chat for me. I want to see some answers coming through. Good, grade 8s. Keep those answers coming. Excellent. Okay, so exactly, there are 3 terms here. Why are there 3 terms? Well, I see I've got a plus sign and a minus sign. Those aren't in brackets, so it's not causing anything chaotic to go on. Because I've got those plus and minus signs, it is separating my terms for me. And so I've got one term of 2x squared, a second term of positive 3y squared, and a third term of negative z cubed. And so in this expression, I've got 3 terms. And I can't remember who, but someone on the chat went a step further and said, because it's 3 terms, it is what we call a trinomial. Now, don't stress too much about the specific names for expressions. That's not super important at this point in time. It is a trinomial because there are 3 terms. Tri means 3. Nomial means expression. So we've got a 3-termed expression. You don't need to know that right now, but for interest's sake. All right, so those are nice and easy. No problems there, hopefully. What we now need to be careful of is when we get a plus sign that is inside our brackets. So what we can see in question D now is that I have got a plus sign, but it's a little bit different to the others because it's inside the bracket. And so we need to take careful note here of the fact that when our plus or minus sign is inside the bracket, we don't consider it when we're trying to figure out how many terms we have. So when plus or minus sign is inside, oh golly, inside the brackets, it is not separating terms of the expression. It's separating terms inside the bracket, but it's not separating terms of the entire expression. Okay, so what that essentially means is that if I look at question D, what I have is 3 times the bracket 2x plus 5. And because I'm not really concerned about that plus sign inside the bracket, essentially all I actually have is 3 times a bracket. And so if I look at the signs that I'm dealing with in the whole expression, so the expression as a whole, I only have a multiplication. And so what that means, sorry, don't know what happened there. And so what that means is that this entire product is 1 term. Yes, there is a plus sign inside my bracket, but signs inside the bracket don't count or don't contribute towards terms for the whole expression. So if I'm looking at the entire expression, it is a multiplication. It is 3 times a bracket. And because multiplication does not separate terms, we have 1 term that we are working with here. So just quickly, thumbs up if we all understand that, thumbs down if that's a bit confusing. Understand that because it's times, it's 1 term, or I'm a little bit confused. Just in the chat, thumbs up, thumbs down.
Yeah, I'm gonna be all right. You'll do more exercises. You will see. I think there's a mixture of good and not good at this moment. But as we do more examples, y'all are gonna be fine.
Okay, so I'm going to try and maybe reword this a bit. So basically what I'm saying here is that I had my words in my head and now they've gone. So when identifying terms, we don't look at the plus or minus signs inside the bracket. Okay, so guys, what I was saying there when I said the sign inside the bracket doesn't matter is when we want to identify how many terms there are in an expression, we don't look at plus or minuses inside a bracket. We only look at the ones outside the brackets. So because this plus sign in D is inside the bracket, it doesn't, I'm not going to look at it right now. I'm going to ignore it. This expression is a product. It is 3 times the bracket. Now, remember we said terms are separated only by plus or minus signs. Because this is a product, because this is 3 times the bracket, that times does not separate terms. And so because it doesn't separate terms, I actually have one entire term that I'm working with here. And so that's why I've said I have one term. The same thing is true when I get to division. So if we look at question E, we can sort of statement over here where we said we don't look at the signs inside the bracket or in our numerator or denominator. I'm just going to say num or denom, because that is in one part of my fraction. And so if we have a look here, yes, if I only looked at my numerator, I would have 2 terms, but I have a fraction here. I can't just ignore the denominator. And so if I take this entire fraction into account, because I've got a bracket divided by the denominator of 3, and because division does not separate terms, I only have one term here. So I just ignore what's going on inside my bracket. I know there's stuff inside my bracket, but I don't need to stress about it when I am identifying terms. So when identifying terms, I don't need to stress about the plus or minus inside the bracket. All I care about is, am I doing division? Am I doing multiplication? What does that then mean? And because I'm saying the bracket divided by 3, the division does not separate terms. And so I only have my one term in this expression. Okay, now grade 8, I know this is a little bit complicated. So as we do more examples, I'm going to identify terms for us and chat about the terms that we have going on so that hopefully we understand a bit more. But take your screenshots of these 5 questions for now. And like I say, if this isn't too clear yet, that's absolutely fine. As we start to do examples, I'm going to keep identifying our terms. And hopefully through repetition, we're going to start to understand this a bit more. But I'll check in with you in a few minutes once we've done an example or 2.
Yep, you guys will feel better soon. Okay, you'll understand much way better.
Cool. Okay, I'm just giving everyone a chance to screenshot. While we're doing that, if there's any questions, you can raise your hand. Otherwise, we are going to look at some examples. So don't, like I said, don't stress if this isn't making 100% sense. But if you have a question, you can raise your hand. Isn't it?
Hello, ma'am.
Hi.
So since you're saying if the equations are like as number D and E, so is it like in other ways, if there is like a division sign or a multiplication sign, do we just say it's one term or?
So basically, yes. If you only have the 3 times a bracket or a number in front and then a bracket right next to it, you're working with multiplication. And so then you only have one term. Obviously, I can combine multiple products together, and we're going to have a look at an example as we go along. But if it is something times a bracket or terms being divided by the same denominator, we've got one term.
Okay, thank you, ma'am.
Good. Okay, just quickly, Lonofefe, for the 5, that minus sign tells us that we are subtracting 5, and it tells us that it is a negative 5. So it's actually doing this, it's doing both. So it is a negative 5, but because it is negative 5, that is telling us that we are taking away or we are subtracting 5. All right, so just, it basically is both of them. Aluta, yes?
Sorry, ma'am, please can I ask if it's going to be 3 plus 9 plus
Sorry, say that
brackets
again.
9. Sorry, please can I ask if it's going to be 3 plus 9 plus brackets 6 plus 9 brackets. Are we going to count them as one
Sorry,
term or two?
where's the 9 coming from?
It's a sum.
Okay, so say that again for me. Let me write it down. 3.
If it's 3 plus 9 plus brackets 6 plus 9, then you close the brackets. Are we going to count it as only one term or what?
Okay, so guys, this is a good example of what do we do when we've got brackets and more terms? And this goes back to Zinhle's question. I don't care about the plus sign inside the bracket, so I'm going to ignore it. But I do care about these plus signs outside the bracket.
Oh, so it's
And
going to
so
be
there are 3 terms that we have in this expression, because the 3 is one term. It's separated by the 9 with the plus, so there's my second term, and the whole bracket is then my third term. Good, well done.
Thank you, ma'am.
Very nice. Okay, grade 8. So I'm hoping that we all have our screenshot. Tandawetu, E is one term because we are using division there. Because it's a fraction, division is my operation. Yes, I've got 2x minus 5, but that's all in a numerator. Remember, your numerator, if it's all over the same denominator, is almost in a bracket. So we don't care about the signs in the numerator. I care about the fact that it is something divided by something, which is division, which means that we are not separating terms with division. Right, so guys, we're going to take a brain break a little bit earlier, just so that you can digest that. And then we'll come back to doing some examples of simplification. So here is our brain break for the day. Again, some of you had asked for some more fraction, word problem solving type of questions. So that is what today's brain break entails. It is a little bit of a trickier one. That's not to say you can't do it, because you definitely can, but you need to think carefully when dealing with or approaching this question. So I want you guys to have a look at your brain break here. Once again, this is because you guys had requested some more fraction problem solving sort of ones. So I'm going to read it for you. Fiona has some sweets. She gives a quarter of them to Michelle and a sixth of the remainder of them to Nina. If Fiona has 25 sweets left over, how many did she have in the beginning? So I want you to try it. Very importantly, though, the question is asking how many sweets did she have in the beginning. So your answer should not be a fraction or a decimal. It should be a whole number. You can't have a quarter of a sweet unless you break it. And we're not there's no broken sweets. They are whole sweets. So I want you to give it a try for the next few minutes. We'll see if anyone gets an answer. If we don't, that's absolutely fine. You'll take a screenshot and you will try it for the next 2 or so days. And on Wednesday, we can have a look. But let's see if anyone can come up with an answer for me for this question. Right, and guys, not the tip or the trick, but what you need to do here is read this question carefully. And this is, I think, where a lot of us sometimes struggle a little bit with fractions, or even just with word problems in general, is the second we start to see words in maths, we start to panic. And unfortunately, there are some sections in maths where we need to be able to deal with word problems or just words and situations. And so getting used to this and reading questions carefully is very, very important.
Let's go, my people. Let's do this. You need to bring your fraction skills.
Okay, I haven't seen a correct answer yet. We're close, but we're not there just yet. I'm going to give you another minute or so. Otherwise, you're going to take a screenshot and you're going to give it a try, and then we'll have a look at it on Wednesday. And guys, if you're getting answers, you can go backwards from it. So if you've got an answer, see if you take a quarter of them to Michelle and you take a sixth of the remainder, do you get 25 sweets left over? So you can always double check yourself with your answer based on the question. Oh, some very close answers. Remember, guys, your answer will not be a decimal or a fraction. Oh, we've got such close answers. Okay, grade 8s, I want you to take a screenshot. Oopsie. And then on Wednesday, we're going to chat about how you can deal with this. Oh, boy, too, you've got an answer for us. Can you explain to us how you got 40? And now this is the thing, guys. You've got an answer, but I need an explanation. Okay, so because we need to carry on Wednesday, Boitu, Daneo, Reese, Bonolo, I want to have an explanation from some of you how we got 40. Muting myself, that's fine. Boitu, you need to raise your hand so that I can unmute you. There we go.
Ma'am, I guessed.
Okay, well, at least you're honest about how you got your answer. Right, so all of you who got 40, this is now my challenge, and even all of you who didn't get 40, I want to know why is the answer 40 for Wednesday. So mathematically, why is it 40? Not I guess, not because Boitu said so. Why is it 40? We will speak on Wednesday about why it is 40. Ay, ay, ay. At least it's one mark.
People. Yeah, we're packing it Wednesday.
Okay, so I'm gonna let you take a screenshot if you don't have the question and you need it before Wednesday. Otherwise, we're gonna have a look at some simplification. But Boitu, I appreciate the honesty of I guess. Honesty is the best policy. And at least you got 1 mark out of, I don't know, 3 or 4 here. Better than nothing.
That was really cool. Yeah.
Okay, guys, so let's have a look at some simplification of expressions. Now, all we were doing initially is seeing how many terms we have. So if we do the same thing here to start off with, because we always like to identify what terms we are working with before we just jump into a question. If we have a look at this first expression, I have got 4 times a bracket. Now, I don't care what's going on in the bracket. I'm going to ignore that for a second. because I've got 4 times a bracket, and because multiplication does not separate terms, I have got, that's an ugly looking line. I have got, it's got even worse. Right, I'm going to try a third time. Better. I have got 1 term in this expression. That is it. What I now want to do is actually what the question asks me to do. And the question is asking me to simplify the expressions. Now, guys, very importantly, whenever we get an instruction of simplify, this often means that I need to multiply or divide first. And once I've multiplied and divided, I want to add or subtract my like terms. Okay, so all of you are jumping the gun. I'm still explaining some things here. Just hang on a second. So simplify means do any multiplication and division first, and then double check if you've got any like terms that you can add or subtract. So yes, Bulela, absolutely. What we want to do here is, because we've got 4 times the bracket, I want to times 4 to the 2y, and I want to times 4 to the 3. Now, what I like to sometimes do is just have a little multiplication block for myself to do my working out. Remember, grade 8s, when we are multiplying, we always want to remember SNV, signs, numbers, variables. So if I multiply positive 4 by positive 2y, a positive times a positive is a positive. 4 times 2 is 8, and then I've got my y. And then I have positive 4 times positive 3. Positive times a positive is again a positive. 4 times 3 is 12. I don't have a variable there, so I don't need to stress about that. And because I've now done my multiplications, I know that my product that I have is 8y plus 12. Now, guys, again, I know it's plus 12 because a positive times a positive is a positive. So I know that the sign for that 12 is positive. And so through doing my multiplication, I have simplified. I've got no like terms here, so this is very important. We always want to check for like terms. These are not like terms. Sorry, my cat's just being chaos. Like terms, remember, have the same variable or exponent. I've got a term with a y, and I've got a constant term, so they're not like terms. And so that means I cannot add or subtract them. And guys, that's very important. If you now start adding things that can't be added, we're getting the wrong answer. Sorry, she's being a bit of a nonsense. Okay. So, I don't know if I'm saying that correctly. Just quickly, SNV, guys, for those of you that might be new, means do your signs first. So positive times a positive is positive. Then your numbers. So for example, 4 times 2 is 8. And then your variables. It's just a little, that's not how to say variables. It's just a way to remind ourselves to multiply and divide values correctly. Right, grade 8. So I'm going to leave that up there for a second. I don't want you to do this question B. I want to just change this. So let's just make this an 8. And I want you to try question B for me. Now, guys, what is very important here is if we look at what we're dealing with a bracket times 4. So we're still dealing with one term, and we're still dealing with a product. And so what that means is that just because the 4 is at the end of my bracket now, it doesn't change what I need to do. I need to times it into my bracket. So I want you to give that a try for me and put your answers in the chat. I'll ask for some hands in a second. But I want answers in the chat so I can see what we're doing. And remember, grade 8, you can only add stuff, or add terms rather, let's maybe use mathematical language, if we have like terms. So like Chipper said there in the chat, you can only add if you have like terms, which means if there are no like terms, you stop. You can't force something that isn't mathematically correct. Right, grade 8s, who would like to raise their hand to explain for us how they did question B over here? Nice, I like that we've got so many hands. Sia, do you want to help me here?
Hi, ma'am.
Hi.
So, ma'am, I said 4 times 2y equals to 8y. Then I said 4 times 8 equals to 32. Then I said 8y plus 32 equals to 40.
Okay, so guys, excuse me, just quickly, if we do our multiplication block, 2y times 4, a positive times a positive is a positive, 2 times 4 is that 8, and then we've got the y. 8 times 4, positive times a positive is a positive, 8 times 4 is exactly 32, and there's no variable there, so it stays 32. Now, just be careful, see, this is our final answer, because again, these are not like terms, so I can't add them together. Because we've got a y here and no y with the 32, I cannot add them together. If it had been 8y plus 32y, then absolutely. But because one has a y and one doesn't, I can't add them together. And so that means that 8y plus 32 is my final answer. Okay, grade 8. So that's very, very important when we are simplifying. Again, I'm just going to take you back up to the top here when we spoke about what simplifying is. You multiply or divide first, and then only do you add or subtract, and then very importantly, like terms. Right, very nicely done. Oh, excuse me, I've got a frog in my throat. I want you guys to try question C for me. I'm just making it a touch smaller so that you can see what we were doing in question A and question B to help you get to an answer for question C. But I want you to try question C based on what we have now done in question A and question B. Right, Zintle, in terms of how we simplify with fractions, we are hopefully going to get to some fraction examples. But, oh, excuse me. Essentially, if we have a fraction all over one denominator, we can separate each term in our numerator to be over our denominator, and we can simplify like that. So we are going to do some fraction examples, so don't stress, we will do some. But essentially, we use distribution in fraction form. So we separate the fraction into individual fractions and simplify like that. Oh, sorry guys, I've got something in my throat.
Let's keep them coming, girl. Remember, you must correct your answers.
Okay, so grade 8, remember, we've got a 4 that has been multiplied with the bracket here, which means that we need to multiply the 4 to every single term inside our brackets. So I just want you to double check that your answers agree with what I've just said. And please remember again that you cannot add or subtract terms unless they are like terms. I haven't asked for any hands yet, guys, so just we're giving everyone a chance to try and answer. Alrighty, would anyone like to raise their hand to explain how we do this question C? Oh, so many hands. Triple, do you want to help us out here?
Hello.
Hi.
So I said 4 times 2x is 8x.
plus 4 times 3y is 12y, which would be 8x plus 12y. And then I said 4 times 1 is 4, which would be 4x plus 12y plus 4.
Perfect. Okay. So guys, there we have it. Again, if you need your multiplication block, that's absolutely fine. Just so that you can see why we got what we got. Positive 4 times positive 2x. Positive times a positive is a positive. 4 times 2 is 8. So we've got 8x. Positive 4 times positive 3y. Positive 12y. And 4 times positive 1 is a positive 4. So these terms are all positive. Now, we don't have to put a positive in front of the 8x because it's our first term, but we do need to have the positives in front of the 12y and the 4. Now, I'm going to pick on someone else here. Apalele, can I add any of these terms together?
Ma'am, you cannot add because they don't have the same signs. 8 and 12 don't have the same signs, and 4 doesn't have any signs, so you cannot add anyone together.
Excellent. So guys, this is our final answer because exactly as Apalele has now told us, these are not like terms. Oh, I'm going to select. Remember, you can only add or subtract like terms. These are not like terms because one term has an x, one term has a y, and one term has no variable at all. They are all different, which means that we cannot add them together. So our final answer is 8x plus 12y plus 4. Right, very nicely done, grade 8. Based on that, I want you to give question D a try here. Okay, while you are giving it a try, you have still got C there for you to hopefully help you. But while you're giving it a try, if you have any questions, you can raise your hand for me and I can help you. Otherwise, you are giving question.
Ma'am,
Hi.
hello. I don't understand, ma'am. When we get the answer, do we use the brackets or do we leave the brackets out?
So once we have multiplied the 4 into the brackets fall away. So our answer won't have any brackets in it. Does that answer your question?
Yes, ma'am, it answers my question.
Okay, so guys, that's actually a very good question. Once you've multiplied, so once you've distributed the number in front of the brackets into your bracket, you have done the multiplication. And so what that means is that the brackets are no longer necessary. There's no more multiplication that we need to do. And so it means that our answer should not have any brackets if we are fully simplifying. All right, what I am going to say for D is please remember, I'm going to scroll up here quickly. We always want to check if we could add or subtract like terms. That's very important. If you don't add or subtract like terms that you have not fully simplified. Right, who wants to raise a hand to help me out here? Okay, Aluta, help me with this one.
So I said 2, because we have an invisible 1 there by x. So I said 2 multiplied by 1 is equals to 2x plus 4, because 2 multiplied by 2 is equals to 4. Then I said plus 3 multiplied by 1 is equals to 3x. Then I said plus 3 multiplied by 1 equals to 3. So because 2x and 3x has the same variable, so I said 2 plus 5, 2 plus 3 equals to 5x, and 4 plus 3 equals to 7.
Excellent. So guys, very important there. Aluta has identified those like terms. We need to do that. So once we've got our like terms, we know that 2x can be added with 3x, and the positive 4 can be added with 3. And so in adding my like terms, I'm getting 5x plus 7. And again, you need to add your like terms, otherwise you have not fully simplified. Right, so what I'm going to do is I'm just going to make that a touch smaller, just so that you can screenshot all of them at the same time. Excuse me. So take your screenshots, and then we're going to look at one with a fraction so that you guys can see how you would deal with that situation. So screenshots. Nobatle, do you have a question before I carry on?
Nobatle, do you want to ask something? Okay, I'm sure it's network. That's why Nobatle cannot communicate with us.
So Nobatle, you're welcome to put it. Huh?
There we go. Hi, Nobatle.
Hi, ma'am. Please explain me example 1.
Nobatle, sorry, say it again. You're breaking up.
I think Nobatle said,
Please,
explain
ma'am,
example number 1.
explain me example.
Okay, so I'm not hearing. If you are talking about example 1 here for A, all we are doing is taking the 4 and multiplying it with the 2y and the 3. So exactly what I've done here in the box. But remember, Nobatle, everything is recorded, so you can go back and rewatch this lesson, all right?
Yes, ma'am.
Alrighty, guys, I'm assuming you've all taken screenshots. So we're going to deal with, excuse me, we're going to deal quickly in the last like 5 minutes or so with what happens when we have a fraction, because that was the question that was asked. So let's see how we deal with this. Now, we will do more examples like this in our next lesson, because obviously we're only doing 1 or 2, but distribution can apply to fractions as well. What I mean by that is, because these have a common denominator, or because they are over the same denominator, and when I say they, I mean the 2 terms in my numerator, we can actually split our fraction. So we can split up the numerator into 2 fractions. So what we would have here is 2x over 2 plus 4 over 2. That means exactly the same thing as the question. All I'm doing is I am separating my fraction to get 2 fractions so that I can simplify each of these terms individually. Now I know I've got 2 terms because of this plus sign. And essentially what I'm doing is I'm taking the 2 terms in my numerator and I'm splitting them. So when we are dealing with fractions, we can deal with it like this. I just quickly want to stop for a second. Imanga Matanda, we can't add 5x and 7, exactly like Kapano said, they are not like terms. We can't add them, we stop there. Right, so it goes back to our fraction. What we now do is we know, because we've done fractions, that we can simplify this. So again, if I just do my little division box, grade 8, let's focus. We've got 2x divided by 2. All I'm doing is I'm writing the fraction with the division, and I've got 4 divided by 2. Again, I'm just taking my fraction and writing it as its division. So again, we can use SNV. This is always helpful whenever we multiply or divide. I've got a positive 2 divided by a positive 2, so my answer is positive. When I get to my numbers, 2 divided by 2 is 1. And then I've got my variable x. Can't do anything with it, it's by itself, so I keep x. When I then get to my 4 divided by 2, a positive divided by a positive is a positive. 4 divided by 2 is 2. And so what I have here is a simplified answer of 1x plus 2. Now, it doesn't matter that my answer doesn't have a fraction. That's okay. Our answer doesn't have to be a fraction if I started with a fraction. If everything simplifies to nothing with a fraction, that's okay. But what I have done is I have correctly simplified my fraction. Now you don't have to write this one here. You're welcome to. I never do. So you really don't have to, but you are welcome to write the one in front of the X. You will not be marked wrong. So when we have fractions, what we do is we split them, right? So we've got like a minute or two. Based on that, I want you guys to try question B for me. So based on what I've just said about the fact that when we have a fraction all over the same denominator, we can split the fraction. I want you to try question B for me. Remember to double check for any like terms that you might have. Pop your answers in the chat. This will be the last question, and then you'll do your poll, and then we'll see from there. But give this one a try.
And that one last question of the day. Let's focus and do it right, my people. Y'all have been very, very good. So it's a lot to learn and you guys are getting it.
Okay, so Dinkley, what do I mean by split? Remember, we split the fraction up. So what I did in question A was I took the 2x and I split that up and wrote it over the denominator 2. And then I took the 4, and because they're over the same denominator, I just write 4 over 2. So I split my fraction up based on what the denominator is. Okay, I'm seeing some awesome answers so far. Keep them coming. Oh, grade 8s, we need to listen. Right, SNV, signs, numbers, variables. I did explain it earlier. So if you go get the recording, you can see earlier on in the lesson my explanation of SNV, but it means signs, numbers, variables. Then in terms of Fanela's question, do you need to simplify? Fanela, you always need to simplify, but remember, you only simplify if they are like terms. Right, grade 8s, who would like to raise their hand to explain this one to me? Bonolo?
Oh, hi, ma'am.
Hi.
So, ma'am, firstly, what I did, I split them. So I said 6xy over 3. Then I said plus 3xy, 3x. Oh, then I said plus 18 over 3. Then
Over
after
3?
ma'am, I
Okay,
said
yeah, sorry.
6 divided by. Then after ma'am, I said 6 divided by 3, which gave me 2. So I added the variables and it gave me 2xy.
Good.
Then I said plus 3 divided by 3 is going to give me 1. So I wrote 1x.
Good.
Then I wrote plus. Then 18 divided by 3 is going to give me 6. Then I wrote equals. Then ma'am, for 1x, I didn't have to write with the 1, so I wrote 2x plus x plus 6.
Perfect. Well done, Bonolo. Very nicely done.
Thank you, ma'am.
Right, so good. So Shana, tell me something. Is this my final? Oh, Shana's left me. Okay, let's pick someone else. Luanle. Oh, Shana, are you there?
Yes, ma'am.
Okay, tell me, is this my final answer? Can I
Yes,
simplify this more?
yes, you can.
Are you sure? Are there any like terms here?
Oh, no, ma'am, you can't. No, you can't.
Good, well done. So guys, there are no like terms. I can't simplify that any further, so I'm done. I end it there. That is it. It is simplified. All right, so whenever you have fractions, the way we deal with that is to split our fraction. So you're going to see the poll pop up now, but here is those two questions that we've just done for you to take a screenshot if you want. Oh, Sherbet. Sorry. There was a question, Lunofefe, what do you mean how? What is how? How what? If you are howing in response to your lender statement, the signs are all positive. You can't have a minus there. So you adding a sign that shouldn't be there will mean that you have an incorrect answer. I'm not too sure where the how is coming from. I'm assuming that. Guys, make sure we're doing this poll.